Hello, everyone. My name is Jānis Marcinkēvičs. I am from Latvia, from Riga. So it's great to be here. So a little bit about my background. I'm a structural engineer for about 9 years now. So I started to work in this field around 2006. So, and since the last year, I'm also acting as a help desk specialist for few structural softwares in Latvia. One of those softwares is RFEM, developed by company DLUBAL. So, and a little bit about, as the topic of today is the Eurocode, so a little bit my background in Eurocodes. When I was just starting my career, it was 2006, then in Latvia we had only our local codes, and basically those codes was like a light version of Russian SNPs. There was just translated, shortened it, and that's all. And in fact, some of the codes, like for example for the steel, was really never released Latvian building code. So in the 90s and in the early 2000s, the only option for the engineer was to calculate according to SNP. So it was quite bad situation actually. So, and then in 2008, so-called dual system was introduced in Latvia. So then engineer has a choice between Eurocode and same Latvian codes. So it was meant to be like a transition period. Initially it was meant to be like 5 years, but there was, I guess, some lack of money and some lack of resources with introducing Eurocode. So only the last year, 2015, this dual system was cancelled. Now it's allowed to design buildings in Latvia only by the Eurocodes or any other codes, but the result must be corresponding to the Eurocodes. So, and actually this period was, I guess, long enough. Yeah, it was time to prepare to transit, but as I know, for many engineers, it still came as a surprise. So now we are here, must calculate everything by Eurocodes, but the knowledge is, in many cases, is not enough. So, and then it's great that there is some softwares which, of course, cannot replace your own brains and hand calculations, but at least it can help, and you can always compare your hand calculations with the software. So that is quite good. So, and one of, in my opinion, best softwares which are meant for Eurocodes is RFEM, developed by company DLUBAL. It comes from Germany. So as in Germany, as the Eurocodes partially came from Germany, so we can say that this RFEM was developed, designed with the Eurocode in mind. So it's very Eurocode-based software. Now there is also possibilities to calculate according to American codes and others, but basics for global is Eurocode. So a little bit about my agenda of my presentation. So I will talk a little bit about the modules that are available in RFEM and how we can make loads according to Eurocode, then about load combinations, and then a little bit more about the steel structures, and in the second half of my presentation about the concrete structures. So as many of the German structural softwares. RFEM is module based, so you have main software which is doing finite element meshing and calculating loads and internal forces, and then you have many of separate modules which deal with the different kind of materials and structures. And then in RFEM, in basically most of those modules, Eurocode has been implemented. So it's only, I guess, one of the 10 main Eurocodes which is not represented by a separate module in RFEM. It's a masonry structure, but still using one for the concrete structure. You can define material, masonry, and do stuff like that. And also, as you probably know, there is coming quite soon one more Eurocode for the glass structures. So in RFEM there is already module for glass structures. And I guess when the Eurocode will be present, you can calculate also that according to Eurocode using RFEM. About the load applications, RFEM has these great features that can help and ease up applying loads, wind loads, according to Eurocode. As you probably know, it's not that easy task to calculate wind loads according to Eurocode. At least it takes some time if you don't have any spreadsheets or made up. So by hand it takes quite a lot to do that. What it is really great for that once you apply this load with some generator, it stays there, and when you change the building, the height of the building, the slopes of the roof, load is adjusted automatically. You don't have to worry about that anymore. And also this is meant for regular buildings, but you can always use multiple instances of these generators, and by combining those you can also deal with more complex buildings. So let's take a quick example. So there is a cool thing that in RFEM in most modules there is already present Latvian national annex and Lithuanian national annex, which is not usual for those big softwares. So by this load generator, we're just showing the bottom of the building or part of the building, and the same way we show the roof of the building. So software automatically recognizes those external surfaces and which elements lies in those surfaces, and then we, for example, can say that we want to apply loads directly only to the, in this example, columns and the top members of the trusses, but not to the wind bracings. So that goes very fast. Okay, and what software does, it automatically calculates all the zones, wind zones, according to Eurocode, and corresponding pressure coefficients or suction coefficients. So, and there is no need for any cladding. Where to apply load, you can directly apply those to the members, to the bars. And you can always check those that this is applied correctly by displaying how the load is applied to separate members. So this is easy to follow up if it's correct or looks correct. So that about the wind load. Very similar load generator there is for snow load. It also includes the national annex for Lithuania. The principles are quite the same. You can choose between flat roof and roof with 2 slopes, but as I said, if there is a roof with many slopes, you can always combine those generators and deal with more complex situation. There is some information from National Annex of Lithuania. So just showing the geometry of the roof. And also telling that we want to apply load only to the trusses, not the bracings. Okay, and then in this case, there is 3 different cases generated where the snow load is more on the one side of the roof and less on the other, and vice versa. And the third case where there's same load on both of the slopes. All right. That about the wind load generators. Of course, you can always add those loads out manually just by using point loads or line loads or area loads. And when the loads are there, so what left is load combinations. We can do those manually. There is a sorry, this one is one more load, or actually not the load, but in Europe, if we calculate the structures according to Eurocode, we must consider effect of imperfections and the forces that might arise because of those imperfections. So in RFEM, we can add those effects to separate members or whole the building. So you can see it adds like deformed initial shape of the columns. So the loads that will arise or forces that will arise because of this imperfection will be taken into account. And those imperfections are treated pretty much like the loads. They are going into the load combinations. So when that, and the last one regarding loads, there is load combinations. And then you can make those manually, or there is a possibility to choose the code, the national annex, and software do it for us. And there is a possibility to reduce the number of load cases, because as you know, there is, I don't know, three live loads for wind loads, snow load, and the total number of possible load combination get quite huge, and even for very powerful computers that might be a problem. There is possibilities to reduce that number. Maybe not will go very deep in those details. Just take a look how those load combinations could be created automatically. So we have there are some load cases. So we are telling that it will be according to Eurocode. You can choose the national annex, and then there you can see the corresponding coefficients and combination coefficients as well. You can change the consequence class of the building, which also affects the load combinations. So then we tell that we want automatic combinations. So in this case, we have all what we could have according to Eurocode, and after that we can go and use some tools to reduce the number if the number seems to be too big for the software or computer to handle that. Okay, so Then that was about the loads, and then regarding the steel structures in RFEM, there is not only one module, there is quite a few modules which allows to deal with different perspectives of steel structures. The very basic is which one allows to calculate the members like columns, beams, members of trusses, and stuff like that. So what it does is automatically makes classification of the cross sections, puts everything in one of those four types, and then also, which is great about the RFEM, that it's automatically recognizes the element, what type of element it is, and makes the corresponding calculations. So by the default, there should be no situation. For example, we have a column and we calculate it just by the axial force and not taking account, for example, buckling. Yeah. RFEM will recognize that this is the column. We should take in consideration the buckling of the column. Of course, after that you can tell the software that, okay, we do not want to check against the buckling, yeah, but by the default we will have pretty good results. Also, what it does, this module, it allows automatically optimize the cross sections. I will show the later the idea. If we find that once cross section is not fully used, or the design ratio is very low, we can tell the software to find the more efficient cross section. And also there is a separate modules for the surfaces and the solids. And as well the connection calculations, there are quite a big library of the connections. Those all are according to Eurocodes. So then let's take a quick example how we can use this module for the members. So there is also national annex of Lithuania present. Just choose the load. There's also a possibility to calculate fire resistance and do some adjusting, like adding lateral restraints, for example, for the beams, or modify the effective length, which by default is 1. You can modify that. So there we have results, and in RFEM, everything that's below 1, it's okay, and everything that's above 1, there's some problems. So, and then there you can see all the results and all the corresponding sections from the Eurocodes. You can always find the formulas according to which that value or that coefficient has been calculated, and there is at the end there is the formula, the final formula by which the element has been calculated. So as I already told, there is a possibility to optimize the cross section. Tell the software to please optimize, and software finds the cross section that is more suitable, or with the bigger design ratio. See, there you can see how it was and what it is now. And you can see results also in the model. So it's quite easy to find the problematic places, and which is also a very important part of the software is a printout report. So if you need as a result, some paper to give to the authorities, for example, you can very quickly make the necessary print screens, or just not actually print screen, those pictures stays connected with the software, so anything changes in the software, the picture will always be updated. And of course all the other results. Okay, that was very quickly about the steel structures. I guess my time is up now.